G'day Brainiacs, welcome to BrainGrade, a channel that brings you some of the most interesting facts from around the world. I'm Mr. BrainGrade, and today I'll be taking you on a deep dive into a topic that's lighting up the news and it's got social media buzzing. It's all about superconductors and a new development with a material called LK99, which is formed of lead, phosphorus and oxygen. And it's thanks to two Korean scientists, who are challenging everything we know about superconductors. But before we plunge into the deep end, let's start with the basics. To start off, we will call this chapter of history, Semiconductors, the origin story. Our tale begins in the 19th century when a physicist named Michael Faraday made an observation that not all materials conducted electricity equally. He probably didn't know then that he was laying the foundation for the invention of the semiconductor. Fast forward to the 20th century and enter Walter Schottky and Robert Richard Pohl, two prominent figures in the field of physics and materials science. They developed the first semiconductor devices in the 1920s, initially used in rectifiers and amplifiers for radios. And no, they weren't trying to invent the latest iPhone, they were studying solid-state physics. Semiconductors, as their name suggests, are materials that conduct electricity, but not always. They can be used in the Goldilocks zone between conductors and insulators. With the right amount of energy, like a bit of heat or light, they allow electricity to flow. But what was their purpose? As mentioned, they were initially used in rectifiers and amplifiers for radios. Their biggest glow-up, however, came in the 1940s when they were used to make transistors, the building blocks of modern electronic devices. You could say that semiconductors went from obscurity to literally running the world in a few decades. Since then, semiconductors have become the heart of modern technology. They're in everything from your smartphone to your car's electronic systems. Without semiconductors, your GPS might still be a paper map. And your video call would be, well, just a regular old phone call. Their role in miniaturizing electronics, while increasing efficiency, has led to the digital age we live in. Now, let's take a giant leap forward to the next level of conduction, superconductors. Picture walking through a crowd where not only does everyone step aside, but the air itself clears a path, letting you glide through without resistance or friction. That's a rough analogy of what a superconductor does. Superconductivity was first observed in 1913 by Heike Kamerlingh Onnes, a Dutch physicist who had the brilliant idea of cooling mercury to the balmy temperature of -269 degrees Celsius. The mercury, in response, became a superconductor, a discovery that earned Onnes the 1913 Nobel Peace Prize in Physics. Superconductors are materials that carry electric current with zero electrical resistance. This is the electrical equivalent of a magic trick. It defies our everyday experiences with electricity where some energy always gets wasted as heat. Imagine using a toaster that doesn't get hot or a light bulb that doesn't emit warmth. That's the sort of energy efficiency we're talking about with superconductors. In more scientific terms, this phenomenon occurs when pairs of electrons, known as Cooper pairs, manage to move through the atomic lattice of a material without scattering off impurities or vibrations, even at absolute zero temperature. It's like a choreographed dance of electrons, perfectly in sync with the music of the universe. And here's the kicker. Superconductors also expel magnetic fields, a phenomenon known as the Meissner effect. When a magnetic field is applied to a superconductor, it will induce currents within the material that create an opposing magnetic field, effectively cancelling the applied field. This leads to fascinating effects like quantum levitation, where a superconductor can be made to float above or below a magnet. Superconductors are incredible, but most only work at temperatures colder than the Arctic. And this is where LK99 and our two Korean scientists come into the spotlight. They're claiming that LK99 can exhibit superconductivity at room temperature, a claim that could redefine technology as we know it. So, how big is this discovery? Well, if it's proven true, it's monumental. So monumental in fact that it could revolutionize technology as we know it. Imagine power grids with zero energy loss, ultra-fast quantum computers, and super-efficient electric vehicles. MRI machines so efficient they could be in every doctor's office. Advanced propulsion technology that could revolutionize space travel. Or even maglev trains that hover above their tracks and move at incredible speeds, making your morning commute feel like a sci-fi movie. With advancements this quick, it's like going from a horse-drawn carriage to an advanced sports car, overnight. If we can find a way to make room temperature superconductors a reality on a large scale, it's not an exaggeration to say that it will redefine every sector as we know it. We're talking an energy-efficient future with potentially unlimited possibilities. But remember, Brainiacs, this is still a discovery that needs to be confirmed and peer-reviewed by other scientists around the world. If it's validated, it will not only change our technological landscape but also our understanding of physics. And that, Brainiacs, is a thrilling thought. So for now, like a good cliffhanger at the end of a movie, we'll have to wait and see what the next chapter holds for superconductors. Thanks for tuning in. Was what you learned here today above or below your brain grade? Don't forget to let us know down in the comments. If you enjoyed this video, please like and subscribe. And as always, I'm Mr. Braingrade, and see you next time.